better get going. Good afternoon, everybody. Welcome to a wintry afternoon of Chem 170 with your host, me, Dr. White. Let me do something first. It's called pin myself. Ouch. Good afternoon. I don't know about you, but I got to spend some quality time with my driveway and a shovel this morning. Can't wait until the snow is over. It's not as fun as when you were about 10 or 12. Not at all. But then again, it's still pretty. All right, important things. First of all, this Wednesday after class, I will send out an email with the password for test number 2 PDF file, which tomorrow afternoon you'll be able to download from D2L. I almost said this system for the wrong school. And you'll have until 11 a.m. Thursday morning to take test number 2 and upload your answers as a single PDF file. I have files in the assignment area, which I think some of you have already used, to use your cell phone to take pictures and then upload those. Now, listen carefully. If you do not have a printer, you can just on a piece of paper write out your answers. You do not have to write out the whole questions or any part of questions. Just put, say, question 1, your answer, 2, your answer, and so on. And that makes your life easier because, hey, life happens. And if you look right up here behind that picture from my favorite movie, Forbidden Planet, that's the printer I got last December. Wow, more than that. And that's because my old printer finally died and it took me a while to find a good one. So I was even without a printer for a good 3 or 4 weeks. But anyways, remember, Wednesday after class, I'll send out the password. Take about an hour to do it. Remember, this is not an open notes, open internet. Get help from anybody else test. I put secret stuff, which I'm not going to tell you, in my test to know if somebody's violated that, and that's called cheating. And I will do what's in my syllabus for anybody who cheats on a test of mine or the final. All right, important thing, don't forget to keep on handing in your labs. They're easy points if you hand it in. And remember, come to my office hours or see me after lab or class for a little while. But on Monday and Wednesday, come to my office hour if you can. And I'll help you out with anything. Remember, in my universe, there's no such thing as a dumb question. All right. By the way, I've got today's game plan right there. And done that. Let's see. Before I forget, did anybody drive by a gas station and think about the gasoline, high price, but anyways, gasoline contains ethanol, that's an alcohol. Did you do that? Or do you happen to look at a bottle of rubbing alcohol and that contains isopropyl alcohol, otherwise known as 2-propanol, that is also an alcohol? Did you happen to look at a bottle of nail polish remover and see that it contains acetone? Nobody calls it 2-propanone, acetone, which is a ketone. Or one of my favorites, did you happen to have any vodka or other hard spirits? If you're legally able to do that, and think about they contain ethanol, which is an alcohol. Remember, organic chemistry is all around you. I stole that from SpongeBob. And it won't hurt for you to think about it outside my class. All right, game plan today. First, I'm going to do my world famous review for test number 2. And next, we will go through the practice problems for aldehydes and ketones. And finally, if there's time left, what there should be, we'll go back and continue with carboxylic acids and their derivatives. And if you forgot, in D2L, and you should have gotten an email, there's a point breakdown and the material covered for test number 2, which will include alcohols, thiols, ethers, epoxides, aldehydes. Oh, I need another hand, and ketones. And that's all on there. And it's broken down just like I've done in the past. There's some general knowledge. I think that's 11 points. Nomenclature problems, I think about 35 points or 34, whatever. And then there'll be reactions. I think that's 60. And that adds up to 105 because there's five bonus points on the test. You pick which ones you want to be bonus points. And I'm gonna have some tea. Oh, that's so good on a winter day. But anyways, don't forget, there'll be 2 or 3, maybe even 4 synthesis problems, which are give the starting materials or the reactants to make this product. Now, for nomenclature, remember there are 2 types of nomenclature question. Here's the molecule, give the IUPAC name. The other is, here's the name, which can also include common names now, draw the structure. For reactions, most of the problems will be give the product or products, except for about 4. Any questions so far? Remember, in my world, there's no such thing as a dumb question. And I'm sorry, this weekend I was pretty busy and I didn't forget, I just didn't have time to rewrite this. Most of this is printed, but where it's written, it's usually just giving nomenclature, which is also available in any of the chapters. All right, let's start out. Alcohol. R group, carbons with a hydroxyl group. How do you name them? You find the longest chain with the carbon with the hydroxyl group, drop the E, add OL. Now, if it's acyclic, you need a number which carbon has the hydroxyl group, and that always has the lowest number. When there's a ring, remember, don't forget to put cyclo for like cyclohexane ring. Remember, I taught you that for test 1. And for ring, you need no number, because if it's the only functional group on a ring, which in my class, that will be true, that carbon with the hydroxyl group will always be water. Now, a common name that also became the IUPAC name, benzene ring with a hydroxyl group, phenol. Now, common names, you take an alcohol, name the R group, excuse me, nose itch, the R group as an alkyl group, and then add the word alcohol at the end. And as I mentioned earlier today, rubbing alcohol contains 70% isopropyl alcohol and 30% water. I don't ever remember seeing on a label 2-propanol, which would be the IUPAC name for an alcohol. Now, how do you make an alcohol? This is the only reaction the whole semester I'll put on more than 1 test. And you learn this for test 1, and it will be possibly it on test 2. And that's if you take a double bond, react it with acid and water. Remember, water is H and OH. You break the pi bond, one carbon of the double bond gets H, the other gets OH, and it follows Markovnikov's rule, which is the carbon with the most hydrogens in the double bond gets the hydrogen, the other gets the hydroxyl group. Now, reactions of alcohols. If you take an alcohol and a carbon attached to that carbon with the hydroxyl group, otherwise known as an adjacent carbon, has a hydrogen. If you take H2SO4, sulfuric acid, and the little triangle means heat. I don't always put the temperature down, but you got to have high heat. You lose water, form a double bond, and this follows Zays's rule. And Zays's rule is you get the double bond if you have two choices, hint, which has the most, listen carefully, carbon atoms directly bonded to the carbons in a double bond. Again, excuse me, getting all choked up over this. Oh no, it's bad humor Monday. Must be the snow. But anyways, you get the double bond that has the most carbon atoms directly bonded to the carbons of a double bond. All right, some more alcohol reactions that are a little simpler. Take an alcohol reacted with HX, an acid, hydrochloric, hydrobromic, hydroiodic, where X can be Cl, Br, or I, the halogens we've been using. You replace the hydroxyl group with the halogen on the carbon with the hydroxyl group. Again, you replace the hydroxyl group with a halogen on the carbon that had originally the hydroxyl group. Now, since HX can react with a double bond, some chemists, I don't know who, I wish I did, came up with SOCl2, known as thionyl chloride, and this replaces the hydroxyl group with a chlorine on the carbon with the hydroxyl group. The benefit of thionyl chloride, SOCl2, you do not, this does not react with double bonds or triple bonds. All right, now I taught you about primary, secondary, and tertiary alcohols. I'll never ask, is this a primary or tertiary, secondary, primary, secondary, or tertiary alcohol on a test? But if you take a primary alcohol and oxidize it, and we use the symbol for general oxidizing agents, bracket O, close bracket, oxidizing agent, you remove a hydrogen from the hydroxyl group and a hydrogen from the carbon it's attached to and form a carbon-oxygen double bond. And later on, you learned that was an aldehyde. Take a secondary alcohol and do the same thing. You remove a hydrogen from the carbon the hydroxyl group is attached to, and the hydrogen from the oxygen, you form a carbon-oxygen double bond, and you get a ketone. Now, tertiary alcohols will not react. And as I mentioned before, but I should mention again, I don't do to my students what I didn't like done to me. That's my golden rule of teaching. And I hated with a passion when our organic chemistry instructor put on test, give the product or product, and the answer was no reaction. I didn't like that. If you want me to give you a product, I'll give you a product, but it shouldn't be no reaction. Therefore, I will never, ever put a problem on my test where the correct answer will be no reaction. If I ask you to give a product, something will happen, which means I will never put a tertiary alcohol oxidized on a test or final. All right, next we talked about thiols. Thiol is the sulfur equivalent of an alcohol, RSH, and they stink. Whoa, do they stink? And you should remember that they're putting natural gas to allow you to smell a leak, because methane, natural gas, is odorless. And unfortunately, I had to tell you this sad, sad story, and it was about the tragedy in Texas where about 160 students and teachers died because of a natural gas leak in their school, and it blew up. Next, I talked about ethers. Ether is oxygen with an R and R prime. Think of it an alcohol where you replace the H with another R group. And remember, R prime is just like X and Y in math, and just different, or it could be the same. Now, I showed you the common name for ethers. Name each R group as an alkyl group, methyl, ethyl, etc., and add the word ether at the end. Now, how do you make an ether? The best way is the Williamson ether synthesis. If you take an alkoxide, RO minus Na plus, or react it with an alkyl halide, oops, I forgot to put X is equal to chlorine, bromine, or iodine. the oxygen attacks, remember organic chemists are violent, we are, watch out, attacks the carbon with the halogen and bonds to that, and you also get a salt. Remember, the oxygen bonds to the R prime carbon that had the halogen on it. Now, I talked about epoxides, but really just ethylene oxide. I'll never ask on a test what's the name of that molecule. 3 atoms in a ring, 2 carbons and oxygen, plus additional hydrogens on the carbons. And I've been really good because I didn't use chemistry industry slang for ethylene oxide, which is EO. I would have, but I stayed away just for you, all of you. And if you take an alcohol reactor with 1 molecule of ethylene oxide, you get this ether alcohol. If you take an alcohol and react it now, N moles or N molecules of ethylene oxide, you get this polyether alcohol. Notice I have CHO, CH2, CH2 in a bracket. How many times is it repeated? N times. Listen carefully. Common mistake on test 2, excuse me, students put the hydroxyl group inside the bracket. It's wrong. Again, the hydroxyl group doesn't go inside the bracket. It's always on the outside. Remember that. And next, I noticed a smile. We got into one of my favorite areas. These are my comfort functional groups. Whenever I think of aldehydes and ketones, I get happy, and I am happy now. Now, what's an aldehyde? Carbon double bond to oxygen with an H and an R group on it. Aldehyde, carbon double bond to oxygen with an H and an R group. What's a ketone? Carbon double bonded to an oxygen and 2 R groups, which they can be the same or different, which is why I have R and R prime. Aldehyde ketone. Remember, ketone is not spelled with a Y, even though it's pronounced that way. All right, nomenclature, aldehyde. Find the longest chain, and don't forget, do I have it here? Remember, carbonyl group, carbon double bond to oxygen, and the carbon in the carbonyl group is called the carbonyl carbon, that I won't ever ask on a test. For an aldehyde, find the longest chain with the carbonyl carbon, the aldehyde, and name it as an alkane. Drop the E, add Al. You can't have an aldehyde in a ring, and because the carbonyl carbon of an aldehyde is always 1, it rocks, you don't use the number. Now listen carefully. Aldehyde ending Al. Alcohol ending OL. Be sure on test number 2, clearly write your O and A, OLAL. You don't want me guessing, is that an O or an A? I've got a 50-50 chance guessing it's wrong, even though everything, I have my jeweler's loopies that I can magnify what you write, but if I still got a guess, I can still be wrong. All right, let's get back to aldehydes and ketones. Now, there's 1 aldehyde. The common name became the IUPAC name. When R is a benzene ring, this is called benzaldehyde. And it won't be on the test, but remember, that's the chemical that gives cherries their smell and taste, and also almonds part of their smell and taste. And if you have any Dr. Pepper, like I do, I always think, oh, benzaldehyde. Now you know he's an organic chemist. All right, next, ketones. Carbonyl, 2 R groups. For acyclic, not in a ring, find the longest chain with the carbonyl carbon, name it as an alkane, drop the E and add ONE. And you need a number. For cyclic ketones, ketones in a ring, do the same thing. Find the name of the ring the carbonyl carbon is, like cyclohexane, cyclopentane, cyclobutane, and then drop the E, add ONE. Now for a ring, the carbonyl carbon is always 1, and therefore you don't need a number. Now I taught you 2 important common names for aldehydes and ketones, which you should know. And that is the simplest aldehyde, and turns out this reacts like aldehydes when R is H is formaldehyde. Nobody ever calls that the IUPAC name, methanol. It's formaldehyde. And Dr. White is a world expert in formaldehyde. I worked for a company that was the largest producer of formaldehyde and other things in the world. Now, when you have the simplest ketone, both R and R prime are methyl, nobody calls this 2-propanone. They call it acetone. Again, this is acetone. Remember, that's nail polish remover, at least one type. And when we come to carbonyl groups, notice I have my, from college days, IMP arrow, meaning it's important. Carbonyl group. You should know how to draw a carbonyl group, carbon double bond to oxygen. You should know how to describe with words what is a carbonyl group. And that's carbon or carbon atoms double bond to oxygen or oxygen atoms. And you can just simply say carbon double bond to oxygen. Now, how do you make ketones and aldehydes? Well, deja vu all over again, as Yogi Berra, the great manager and baseball player, manager of the Yankees, used to say. He had a lot of great sayings. My favorite one, it's deja vu all over again. Take a primary alcohol, oxidize, you get an aldehyde. Secondary alcohol, oxidize, you get a ketone. We already went through this, so I'll move on. Now, you should also know Friedel-Crafts acylation. And what you do is take benzene, react, this is called an acid chloride, you need aluminum trichloride, and you replace the chloride atom or chlorine atom attached to the carbonyl with a benzene ring. And this is a way of making aromatic ketones. And I talked to you about how some aromatic ketones are sunscreens. All right, now reactions of ketones and aldehydes. If you notice right here on page 6, I have carbonyl, R prime, and H in bracket, R double prime. When R prime is hydrogen, it's an aldehyde. When R prime is carbons, it's a ketone. So both ketones and aldehydes, especially cycloketones, undergo the following reactions. Take 1 molecule of an alcohol, an acid catalyst, H plus is acid catalyst. Keep your eye on the carbonyl carbon, notice got the dot there, and what's attached to it, R prime or H and R double prime is still there. Open up double bond, becomes OH, and the OR from the alcohols on that same carbon. Now, if you take an aldehyde or ketone now, react it with 2 molecules of alcohol and acid catalyst, you get what's attached to carbonyl carbon, R prime H, and I forgot the double prime here, sorry, is still attached. You have 2 oxygens, and each oxygen has the R group from the alcohol. Now, a special case, which I've talked about, to protect ketones and aldehydes, just like an umbrella protects you from the rain, is if you react ethylene glycol, COH, CH2, CH2, OH, and acid. Now, if you look at ethylene glycol right here, it's got 2 alcohols in it. So it's really this reaction right here. And what's attached to carbon, carbon, R prime and R double prime or H still there. These 2 oxygens from here attached there. What's attached to them? CH2. Now, see the line between the 2 CH2 groups right here? Students forget to put that in, and I mark it wrong because you don't break carbon-carbon single bonds. And time out for a commercial from Dr. White. It's time out for a public service announcement, not really a commercial. Your friend on test number 2 is how many bonds to carbon? Oops, let me get that fixed. How many bonds to carbon? 4. Remember, when you write a structure, you see 3 or 5 bonds to carbon, or 6, and I saw that once. Oh, did I start laughing? Then I'm wrong. But anyways, don't. The other thing that will be your friend on test 2 will be, do you break carbon-carbon single bonds? No. I'll say that again in slow motion. Do you break carbon-carbon single bonds? No. Really, it is your friend also. Which is why I just did a public service announcement. All right. Remember these last 2 reactions, this one, and the next 2, these 2, I will never give a synthesis question, but I will ask you to give the product or products. Now, once you get a hemiacetal, hemiketal, how can you tell? There's only 2 places in all of organic chemistry I know where you have 2, listen carefully, single bonded oxygens to the same carbon. This is it. When you add acid and water, you get back the aldehyde or ketone plus the alcohol you would have used to make that acid, hemiacetal or hemiketal. And again, the other case, same thing, 2 oxygens that are single bonded to the same carbon. And I forgot to double prime up here again, sorry. If you add acid and water, get back the aldehyde or ketone plus the alcohol you would have used to make that. Now notice I got the tiny 2 in quotes. On my test, I asked, give the organic product or products. You don't have to balance them. So if you don't want to put that 2 there, that's okay. All right, now let's look at a Grignard reagent. If you take an alkyl halide, R can be chlorine, bromine, or iodide, react it with magnesium, you get the Grignard reagent. Remember, MgX is on the carbon that had the halogen, and the magnesium is bonded to that carbon, and the halogen is bonded to that. If you wrote down RXMG, I will mark it wrong. Now, once you get the Grignard reagent made, you can use it in the great reaction that my hero, Victor Grignard, just created. And that is, if you take a ketone or aldehyde, first step reacted with a Grignard. Oh no, this file's been attacked by the dreaded oxygen virus. And second step, H plus and H2O. The O fell out. If you find an oxygen rolling around, let me know, I'll put it back. Oh, bad joke again. But anyways, this should be water. You form a carbon-carbon single bond between the Grignard reagent, carbon that had the MgX on it, and what was the carbonyl carbon. This attacks that and forms this. This reaction right here, ketone or aldehyde reacting step 1 with a Grignard reagent, second step acid water. I will never give a synthesis problem on, but I will ask you to give the product or products. Now, carbon oxygen double bond ketone or aldehyde, pi bond sigma bond. If you add hydrogen to catalyst, you can break the pi bond, and each atom of double bond gets the hydrogen, and you form an alcohol. Now, this will react with double bonds, carbon-carbon. So H.C. Brown of Purdue, Dr. Brown, came up with a new reagent he had invented and won the Nobel Prize for. That's LiAlH4, lithium aluminum hydride. If you take a ketone or aldehyde, oh, look, you should know the synthesis problem for that. Both of these, And first step, reacting with lithium aluminum hydride. Second step, acid and water. You do the same thing as above. You break the pi bond. Each atom of double bond gets a hydrogen. The beauty of lithium aluminum hydride is this will not react with a carbon-carbon double bond or triple bond. And finally, remember the carbon attached to the carbonyl carbon of an aldehyde or ketone, the alpha carbon, has acidic protons. And what does that mean? You add a base in the presence of a solvent, in this case, water. You pull off that proton from the alpha carbon of one aldehyde to form the enolate anion, and that attacks the other carbonyl carbon, opens it up to an alcohol, and you've done once again that special thing, make a carbon-carbon single bond. And that's my review. Now, before we move forward, the question says, are you done? But let's pretend the question says, was the review helpful? And this is anonymous. All right, that's by popular demand. I'll keep on doing this. Thank you for your responses. All right. You know, with the snow and everything, I'm in the mood for some fun. So let's have some fun. How do we do that? It's time to play that fun game. And that fun game is circle. Circle and name the functional groups, 2 points each. So let's have some fun. And there you go. Have some fun. Remember, the way we play that game, this game, is circle and name the functional groups, 2 points each. Have fun. And when you're done, give me a thumbs up. Thank you, Stephanie. And thanks to the rest of you are giving thumbs up, but please be patient. Try and give everybody time to finish. All right, let's check how everybody's doing. All right, looks like everybody's done. So I'm going to get to work. How do you play this game? Circle and name the functional group, 2 points each. You look for something that's different. Whatever not a carbon or hydrogen atom or carbon-carbon single bond, that's where the fun is. Oh, look. Yeah, let me do this, have some real fun. Hydroxyl group on a carbon, and that's an alcohol. And if you circle a few extra carbons, don't worry. Did I tell you I'm that close to the person who grades the test? Me. Oh, look, another oxygen right here. We got carbons, carbonyl, hydrogen, and this is an aldehyde. Next, an oxygen here with carbons here and here. That's an ether. Ooh, another oxygen right here. And it's attached to carbon, carbonyl group, carbons here and here. And that's a ketone. And finally, in C, I think I threw in everything but the kitchen sink. Ooh, oxygen here. Double bond this carbon, carbons here and here. That's a ketone. Ooh, other oxygen with a hydrogen on a carbon here. Oops. I forgot to circle things here. If you put in an extra carbon, that's okay. All right, here we have an alcohol. Carbon, carbon, ooh, an oxygen, carbon here and here. And we have an ether. Are we done? No, one more oxygen. Double bond to carbon, hydrogen, carbons here. And that's an aldehyde. And that's how you play that fun game. Circle and name the functional group, 2 points each. I hope you enjoyed playing that fun game. All right, how are we doing time? We're doing good. And that's not the slide I want. This is the one I want. All right, let's proceed with the aldehydes and ketones problem set. There are 2 or 3 mistakes in here. I'll point them out. But, ooh, time out for a quick Dr. White story. Right after I got my PhD, or I should say, right after I passed my oral exam, PhD oral exam, not fun time. It was a couple hours of not fun, but very important life's work on the line. Afterward, I got my PhD, I passed, yay. And a couple days later, when I was ready to leave Michigan State, I went and said goodbye to my advisor, who I'd been with for 5 years, Dr. Roosh, who I will forever be grateful, because under his mentorship, he and other people in the research group too, trained to be synthetic organic chemists. And I was saying goodbye to him, and he said, I got some advice for you. And he said, what? I said, what? He said, once you get your thesis printed, never open it. I said, why? He said, you open it, you're going to find a mistake. Be a tiny mistake, even though I proofed it, you proofed it a number of times, another faculty member proofed it. I know you had 4 people in our group proofed it. There's going to be mistakes. And I learned that before, because when he wrote his own book, I was one of the people he asked to proof it. I proofed it a number of times. After it got published, there were still a few minor mistakes. So that's why I'm telling you the story, because when I do a problem set, I try not to make mistakes, but they slip in. By the way, twice, the first 3 years after I got my PhD, I had friends over and I had my thesis on a coffee table. Someone opened up, oh, what's this? And immediately I saw a mistake. I hide the thesis now. I don't show it to anybody because I'll find another mistake. All right, let's get to work. Thumbs up, people. I haven't done this in a while. Everybody see aldehydes and ketones problem set on your screen. Thank you. All right, let's do this. Question is, A, or any of these, give the IUPAC name for the following. What's different? Carbon, double bond oxygen, hydrogen, carbon's here. That's an aldehyde. Find the longest chain with the carbonyl carbon. 4, butane, drop the E, add Al, butanal. And I always, which you don't have to, I capitalize some letters, and it's a bad habit of mine. When I keyboard, otherwise known as typing, I don't do that. And here, there's no number because the carbonyl carbon is always 1. Now, next one, we have a carbon double bond to oxygen. Excuse me, carbon's here and carbon's here. Ketone, longest chain 4. Drop the E, add ONE, butanone. But since this is acyclic, what carbon is the carbonyl carbon? You number from the end of the chain. So the carbonyl carbon always gets the lowest possible number of, if there are other alkyl groups, they get, this has priority. Here you don't have that case. That's 2-butanone. Now C, oh, oxygen double bond to carbon in a ring, carbon's here and here. It's a ketone, cyclic ketone. How many bends in a line? 6. Cyclohexane, remember the cyclo, drop the E, add O-N-E, cyclohexanone. You don't put the number 1 here, so everybody knows that carbonyl carbon is number 1. And carbon 3, it's your old friend, the methyl group. And carbon 4, it's an isopropyl group. Now, remember, I am not holding you to the IUPAC alphabet rule. I hold myself to it. And therefore, if on a test you put down 4-isopropyl 3-methyl cyclohexanone, I would give you full credit. Don't tell the IUPAC, please. And here we have a bigger aldehyde, carbonyl with hydrogen carbons. What's the longest chain? 7. Heptane, drop the E, add Al, heptanal. And carbon 3 and 5 are methyl groups. So it's 2-di, remember 3 is tri, dimethyl. When you see dimethyl, you need 2 numbers, and they're on 3 and 5. And same thing with a ketone. Here we have what's the longest chain with the carbonyl carbon, 9, and we have nonane, drop the E, add O-N-E, known and known. Say that 5 times quickly. Yeah, you don't have to. And what carbon is the carbonyl carbon? 3. You number from the end to give that carbon always the lowest number. And carbon 6, there's an isopropyl group. Now, if we look at 2, draw the condensed structure for the following organic molecule names. How do you decode this? You start from the right and move left. Al ending aldehyde, if that were E, it would be hexane, 6 carbons. The end carbon is the aldehyde. Remember, I warned you that since I learned from my instructor, organic chemistry, where he always put the oxygen in aldehydes and ketones on the right, I do the same thing. Good habits I don't change. And therefore, hexanal. Now, 3-octanone, O-N-E ending, ketone. If it's an E octane, 8 carbons, where's the carbonyl carbon on carbon 3? I started from this end, 1, 2, 3. You could have started from this end also, 1, 2, 3. They're the same molecules. Is this my right, left hand, or is this? Oh, you're just rotating it, molecules rotate. You should know this is the structure for acetone. This is a structure for formaldehyde. And if we look here, 2-tert-butyl cyclopentanone, start at the right, O-N-E ending, ketone. That were an E, cyclopentane, pentane 5, cyclo 5-membered ring, carbonyl, oxygen, that's my cyclopentane, and carbon 2, one of my favorite groups, a T-butyl group. And the rest are just similar. And let's move on to give the organic product or products for the following. I'm oxidizing this. What do I have? A primary alcohol. Oxidizing it, I get an aldehyde. Here's our, remember, you don't break carbon-carbon single bonds. Secondary alcohol, by the way, that's a ring, not a square. And you oxidize it, you lose a hydrogen from the ring, which you don't see, and this hydrogen form a carbon-oxygen double bond, and you make a ketone. Now, one of the things I've done in the next 2 problems, put a big, scary molecule. No, if you know what to look for, remember, play circle and name the functional group. Secondary alcohol, oxidize it. The only thing that changes is you lose these 2 hydrogens, you form a carbon-oxygen double bond. Everything else comes along for the ride. Same thing in D. Now, if we look at E, we'll have to say, it's time for a break and for me to get up and stretch. Yeah, I need to, otherwise my muscles in my legs start cramping. That's a fun thing about being on your feet all morning and also playing with my driveway. So 5-minute break. I'll see you at 1:55. Uh-oh, I'm late. Time to get going. All right. I was talking about chapter of the aldehydes and ketones problem set, whatever chapter that is, I don't remember. And we're talking about Friedel-Crafts acylation. Take a benzene ring, acid chloride, or carbonyl chlorine, attached to the carbonyl carbon. It's called an acid chloride. I'll never ask that on a test. Aluminum trichloride, and you form an aromatic ketone. This is one of those special reactions where you form a carbon-carbon single bond. Very special, very rare, very important. And notice I gave you different R groups, and you get different aromatic ketones. Now, let's go through the next one by taking, what is this, an aldehyde or ketone? Remember, identify the functional group. Second molecule, carbon-carbon OH group, alcohol, acid catalyst. There are different ways I could write it like this or like this. And what do you get? Keep your eye on the carbonyl carbon. What's attached to that is still attached to it, R prime or H and R double prime. And you open this up to OH, and the OR from the alcohol is bonded to that same carbon that was the carbonyl carbon. And here's the same reaction, but with a ketone. And now, if you take, notice what is this in B? I have carbonyl, carbons here and here. That's a cyclic ketone. Now, could have been an aldehyde. And what do we, the number 2, that's unusual. 2 molecules of an alcohol, acid catalyst. Keep your eye on the carbonyl carbon. What's attached to it, R prime or H or R double prime, is still attached to it. You open up the carbonyl or change it to 2 oxygens going to that carbon. Each one has an R group from the alcohol. Now, the carbon with the hydroxyl group is the carbon OR that the oxygens bond to the R group. And in this case, ketone, cyclic, is still attached to that carbon. 2 oxygens, my R is isopropyl. And here I have an aldehyde, same reaction. And what's attached to the carbonyl carbon, H, and a benzene ring. Remember, alcohol will not react with a benzene ring under these conditions, so it doesn't. And on that carbon, you have 2 oxygens. And what's my R group? Ethyl. Now, once you make an acetal or hemiacetal or hemiketal, add acid and water. Remember, when you see 2 oxygens on the same carbon that are single bonded to that carbon, you'll get acid and water will break it back down to the aldehyde or ketone you would have used to make that molecule, plus in this case, the alcohol. And if you want to put a 2 there, you can, you don't have to. And here I have different R groups. And I just realized, guess what I didn't put down there? Let's do E first. What do we have? Carbon with 2 oxygens single bonded. On that carbon, R prime, R double prime. And on the oxygens, the same thing, R. Acid and water. And you get back the aldehyde and ketone plus the alcohol you would have used to make that acetal, or in this case, ketal. So what's R? Methyl, carbonyl, R prime, ethyl. And on the oxygen, the same R group gives me this alcohol. The carbon with the oxygen here will be the carbon with the hydroxyl group here. Now, what did Dr. White forget to do? The following. So if we look at this, what's different? This carbon has two oxygens bonded to the same carbon. One has a hydroxyl, one has carbons attached to as a hydrogen, but it could be R group, R prime. And here we have R double prime. So this is R prime, R double prime, R. And what do you get? Acid and water. You get back. Keep your eye on the carbon with two oxygens. What's directly bonded to it, H or R prime and R double prime still there. This becomes the aldehyde or ketone, plus my R group here gives me this alcohol. So in this case, here's my carbon with the two oxygens. What's attached to it? Hydrogen and an ethyl group. It'll now have a carbonyl plus my alcohol. What's our methyl? So you get methanol. And now let me give you one to work on. And remember, these are the building blocks that chemists use and also Mother Nature to do things, to make things. Your turn. What are the two? And on a test, I would do this to let you know there are two products you have to write down. So it's your turn to have some fun. And if you finish early, please be patient. I try and give everybody time to finish. All right, I think everybody's done. Let me do it. If I look here, I say, what's different? What's not carbon? What's not? Ooh, oxygen here, oxygen here. They're the same carbon. And it's this reaction. I'll call this R prime and this R double prime. And right here, I'll call that R. So it's attached to the carbonyl carbon, or a carbon with two oxygens, got ahead of myself, becomes the carbonyl carbon. That's an ethyl and a methyl group. And then my alcohol The carbon with the oxygen is a carbon with the hydroxyl group. Do you break carbon-carbon single bonds? No. So I have 3 carbons. And notice the N carbon is attached to the oxygen, so that will have the hydroxyl group. And that's how you do this reaction. Now, I think I told you my secret, how to do extra practice problems. Well, if you got this general reaction, well, do I want to make R prime hydrogen or how many carbons? Oh, in this case, I said I'll make it 2, but you could have made it hydrogen. And then I could have made it in a ring too, but I didn't. Then here are double prime. How many carbons? 1, 2, 3, 4, 5, 7, a ring. And I made a 1. Then our how many carbons? 1, 2, 3, straight or isopropyl. If I pick 3, I picked then propyl. And if you want, come to my office hours, and I'll always tell you how if you did your own problems correctly. All right, if you have a ketone or aldehyde reacted with hydrogen and catalyst, catalyst can be nickel, platinum, or palladium. You break the pi bond, and each carbon of the carbon or each atom of the carbon oxygen double bond gets a hydrogen. In this case, you can write this either way, like this or this. And if we have this aldehyde reacted with hydrogen and catalyst, break the pi bond, each atom of double bond gets a hydrogen. And that's probably the most expensive way I know how to make alcohol. Now, if you have a new reagent, first step, lithium aluminum hydride, LiAlH4. What do we have that's different here? Carbon double bond to oxygen. Remember, look for what's not carbon or hydrogen atom, and that gets your attention like that, or better yet, like this. Hold on. I have to throw that in once in a while. And you have a carbon double bond to oxygen, carbons here and here, ketone, could have been an aldehyde, lithium aluminum hydride, LiAlH4. Second step, add some water. You break the pi bond, each atom of the carbon oxygen bond gets a hydrogen, which in this case, D is this. In E, this is another expensive way to make ethanol. And finally, F, we have, again, lithium aluminum hydride, acid and water, break the pi bond between the carbon and oxygen. You don't show a hydrogen on a ring. So the answer is here. I threw in the carbon here, that was the carbon here, but you don't have to put that in there. Next, oh no, I forgot another thing. Let's practice the following. And the question is, give the organic product or products for the following. And what's different? Ooh, halogen on a carbon, RX. Remember, X can be chlorine, bromine, or iodine. And we're reacting with magnesium metal. And what you get is the Grignard reagent. What's my R group? Here, do you break carbon-carbon single bonds? No, so I have 5 across. Now, this is important. What carbon has the halogen? This is the carbon to magnesium, in this case, halide, which in our case is chlorine, is bonded to. And I know there are 4 bonds to carbon, so I can put in my hydrogens. And the magnesium chloride counts as one bond to carbon. And since I didn't give you any practice problems, here's one for you to try on your own. All right, I think everybody's done. What's different? Ooh, bromine on a carbon, halogen plus magnesium, that's different. And what do we get? We get the Grignard reagent. And what, remember, X can be chlorine, bromine, which is in our case, or iodine. And what's my R group? 3 carbons. You break carbon-carbon single bonds? No. Which carbon had the halogen will have the magnesium halide on it? The center one. What's X? Bromine. And there you go. And again, you pick other R groups and practice on your own. And halogens too from these 3. Now, once you have the Grignard, you react it with a ketone or aldehyde. And if we look at A, this is a ketone. Look at number 1 above the arrow. That's CH3MgI. That's a Grignard. I don't have it here, but X can be chlorine, bromine, or iodine. Second step, acid and water. Watch closely. The carbonyl carbon, what's attached to it, R prime hydrogen, R double prime, is still attached to that. That opens up the hydroxyl group, and then you make something very special, very rare, very important, a carbon-carbon single bond with the Grignard reagent. And the carbon with the halogen, or MgX, not the halogen, will be the carbon bond to the carbon that was the carbonyl carbon. And if we look at C, ooh, I have a ring, but it's a ketone. And what's attached to that carbon is still attached to it. It's a Grignard first step, second step, acid and water. At that carbon, you'll have a hydroxyl group. And then what carbon is the Grignard attached to? The center one. So that's the one that will be bonded to what was the carbonyl carbon. Now, if you look at the ketone in C, and there's a reaction product, that alcohol, I know of no easy way to make it, or even difficult way to make it. But with a Grignard reagent, it's child's play. I don't know about child's play, but it's real simple. And finally, the last page, yay, we have, ooh, an aldehyde reacting with itself, the same aldehyde. I forgot the water on test 2. I won't forget water. Oops. And NaOH, remember, the alpha carbon of an aldehyde and a ketone too, but for this test, I'm just going to end class. I'll stick for this reaction with aldehydes. You take off a hydrogen proton, you form the enolated anion, it attacks the other aldehyde, carbonyl carbon, and forms an alcohol. And it's called an aldol reaction, which I'll never ask. What's attached to the carbonyl carbon is still there. And then this forms a bond to the other aldehyde and opens it up to an alcohol. And if I have, ooh, this is pretty. This aldehyde with a benzene ring. This one, my R group is a benzene. Here's the world's longest carbon-carbon single bond. But to fit everything in there, you need to do that, unless you write micro, which I don't. And that's how you do it. And the last one, here's the mistake. This bottom here has an extra CH2 in it. Instead of 3 CH2s, there should only be 2. Again, the answer for F is a mistake. Oh no. Wait. But anyways, it's got an extra CH2. And with that, anybody have any questions? I'm all ears, and I am. They tell you one of the things that your body keeps on growing. If you look at older people, their ears are big. Well, at least mine works still, sort of. All right, since there are no questions, I don't want anybody to know I'm being nice to you. On test 2, students have certain problems with a couple reactions. And I like to go back and practice them with you. And this way, you won't have problems with them. All right, let's look at this one. What do we have that's different? Ooh, oxygen, double bond to carbon with hydrogens and carbons, and that's an aldehyde. Now, it could have been a ketone where R prime is carbons, not H. And what do we have here? Ooh, carbon with a hydroxyl group and alcohol acid catalyst. Keep your eye on this carbon. What's attached to it, R prime or H, and R double prime is still attached to it. It opens up to an alcohol, not an alcohol, OH group and OR, and this hemi-acetal, hemi-ketal. This is R prime, R double prime, and R. The carbon with the hydroxyl group is the carbon this oxygen is bonded to. So I'm going to write this carbon here first, this one here. What's attached to it, R prime, H, R double prime, methyl, OH, oxygen, what's my R group, isopropyl. And that's supposed to be an H right there. And that's how you do it. Your turn. Give the organic product or products for the following reaction. 3 points each. When you're done, give me a thumbs up so I know to start taking a poll. I see a couple people are done, but you'll have to wait. All right, I think everybody's done. So let's take a look at this. What's different here? Ooh, carbonyl, carbon double bond to oxygen. Carbon's here and here. It's a ketone. Could have been an aldehyde, but it's a ketone. This is our prime and our double prime, and they're the same. What's different here? Carbon, 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 hydroxyl, ooh, alcohol, and acid catalyst. And what do you get? What's attached to the carbonyl carbon is still attached to it. Then this opens up to an alcohol, oxygen, and this R group is attached. So here we have our R. So I'm going to take a look at this carbon, rewrite it, opens up to an alcohol. What's attached to it, our prime or H and our double prime, two methyl groups. And then oxygen. What's my R group? 3 carbons. Which carbon has the hydroxyl group? The N carbon. And therefore, that's the carbon that will be bonded to the oxygen in our product. I just got ahead of myself. And let's take a look at this one. What are we reacting here? An aldehyde, but it could have been a ketone. What are we reacting with? Ooh, 2 and carbon, carbon, OH on a carbon, alcohol, acid catalyst. Keep your eye on this carbon right here. What's attached to it, our prime, our double prime is still attached to it. And now, important, we have the 2 alcohols, and you get an acetal or ketal. So this carbon right here, I'll draw what's attached to it, our prime, our double prime. In this case, it's a hydrogen and a methyl, oxygen, oxygen, and what's my R group? Ethyl. And there you go.
Could you scroll up for a second?
Of course.
Thank you.
Tell me when you're done. Remember, I warned you, I got the fastest mouse wheel finger this side or the other side of the Mississippi River.
I'm done. Thank you.
You're welcome. And here's one for you to do. Remember, these are things students have trouble with, so I'm giving you some practice, a little extra practice. One of the problems on Zoom when everybody keeps their camera off, it's hard for me to tell when you're done, which is why I use the poll. Oh, I forgot to do that. All right, let's do this. What do we have that's different here? Ooh, an oxygen double bond is carbon. Carbon's here and here. That's a ketone. But it could have been an aldehyde, but it's not. Remember, cyclic ketone, R and R prime are connected together. And we're acting with not one, but two carbon hydroxyl group alcohols. Acid catalyst. Keep your eye on the carbonyl carbon. What's attached to it, R prime, or if it was a hydrogen, but it's not in this case, our double prime. Remember, in a cyclic ring, R prime and R double prime are bonded together. This now has this and this. And what's R and R prime? My ring. So I'm gonna keep my eye on this carbon, which is this carbon right here, which is this carbon. I have two oxygens. And what's my R group? Methyl. Now, if you have this, what can you do with it? Well, let's look at this one first. And if we look at this, what's different? Ooh, not one, but two oxygens, single bonded. That's the important thing. Single bond to the same carbon. And what we have here is an hemiacetal or hemiketal. In this case, the hemiketal. Reacted with acid and water, like what's in your stomach, and you get back the carbonyl ketone you would have used to make that acetal or ketal. Keep your eye on this carbon, which becomes this carbon, double bond to oxygen, plus here, this alcohol. And that was how you reacted with acid to make that. And what's my R prime? Hydrogen. What's my R double prime? Methyl. What's my R group? And propyl. The carbon with the oxygen here will be the carbon with the hydroxyl group here. So let's do this carbon first. Attached to it, R prime or H. What's our double prime? Methyl. And our alcohol, R, is N-propyl. And that's what you get. I'll wait until you're finished writing it down. All right, since nobody's yelling at me, I'm going to move and give you a problem to try. And here you go. Have fun. 3 points each. Give the organic product or products for the following reaction. And don't forget, sometime evening or tomorrow morning, a video of our class today will be on my YouTube channel, which is becoming world renowned and popular. Actually, it's getting popular. I'm getting like 35 hits, and there are not 35 people in our class. Plus, some of you are going back 6 or 10 times. It's voting time. All right, looks like everybody's done, so I better get to work. If we look at this molecule, what's different? What's that carbon? What's, oxygen here and here to the same carbon. One's a hydroxyl group, one's oxygen with carbons. I've got carbons here to that carbon here. And this R prime could have been hydrogen, it's not. Acid and water. See what happens when you shovel too much snow? If you bought that one, I got a version down Chicago to sell you. All right, keep your eye on this carbon. It's got 2 oxygens, single bond to it. What's attached to that carbon, R prime or H. Our double prime becomes a ketone or aldehyde. And then this group right here becomes an alcohol. And what's my R prime and R double prime? The ring with the methyl group. So you break carbon-carbon's single bonds. Oh, that's an awful looking ring. That's better. No. Now this carbon here is this carbon here, which is this carbon here, which is this carbon here. which is now a carbonyl. And what's my R? Methyl. And there you go. And let's continue on. And if we look at the following, what's different? Ooh, oxygen here, single bonds, the same carbon with carbons on those oxygens, and a hydrogen and carbons. And if we look at this, we have this. Now, the H could also have been R prime carbons, and this is our double prime. And this is an acetal or ketal, which I'll never ask you to identify on a test or final. And what we get back, what's attached to the carbon with the two oxygens is still directly attached. And now becomes a ketone or aldehyde. And then right here, these right here are my R. And what we get here, an alcohol. Can I make a 2 any smaller? Maybe not. If you want to put a 2 there, you can. You don't have to. So what's our prime? What's our double prime? And keep your eye on this carbon. What's attached to it? Our prime. And our double prime is still there, which is this one, which is double bond to oxygen. Plus, we get our OH, the alcohol. What's our group 3 carbons? Carbon with the oxygen here is the carbon with the hydroxyl group here. And for those who must, you could put a 2 there, you don't have to. All right, let me give you one for you to work on before we take our break. And there you go, one for you to work on. What would be the product or products? And on a test, I would do this to let you know there are 2 things, 2 organic products. I'm so proud of you guys are getting the hang of this tough stuff. I think everybody's done. Does that feel good or does that feel good? You're learning something that everybody else says is impossible. You're finding out it's not, it's fun. All right, let's do this. What's different? Carbon here in the ring with oxygen here and here. On each oxygen, I have carbons. Then I have this right here is attached carbons here and here. I could have had a hydrogen there, I don't. Acid and water, remember you can find that in your stomach. And keep your eye on this carbon. What's attached to it, our prime or hydrogen. Our double prime is still there, and this becomes a ketone. And the R group here becomes this alcohol. If you must, you could put a 2 there. Well, I can get small. All right, what's our prime and our double prime? Well, they're connected together in this ring, which is all of this, that one too. So I'm going to draw this ring. Don't forget the isopropyl group, because you don't break carbon-carbon single bonds. And this carbon here with 2 oxygens becomes this carbon. So double bond to oxygen. And then my alcohol, R, is methyl. For those who must, you can put a 2 there, you don't have to. And that's how you do it. If I look at the clock, instead of rushing, I'm going to give you an extra 60 seconds on our break. So come back at 2:50 and we'll continue. I'll see you at 2:50. Time to get going. All right, one more reaction I'd like to cover, what students have problems on. Shh, don't tell anybody, I'm being nice. On test number 2 is the following. Aren't you glad I've taught this class once or twice or 5 or 10, 20 times before? Oops, that's not what I wanted to do. This is what I want to do. Let's move the arrow down there. And the question is, what's the organic product or products for this reaction? And if we look here, we have what's different. Ooh, carbon double bond to oxygen, hydrogen, but it could have been an alkyl group, R prime, but it's a hydrogen, and carbon's here. We have an aldehyde here. Could have been a ketone. What's different here? Carbon, magnesium halide. We have a Grignard reagent. And second step, acid and water. H plus, remember, is acid. Like sulfuric acid was generally, there are other ones that I don't teach you in this class. Keep your eye on the carbonyl carbon. What's attached to it? R prime and H. And our double prime is still attached. And this opens up to an alcohol. And now we do something very special, very rare. This attacks that and forms a carbon-carbon single bond. And for that, Victor Grignard won the Nobel Prize, which he richly deserved. So what's our prime? Hydrogen. What's our double prime? Methyl. What's our triple prime? Remember the carbon with the MgX. Remember X here is chlorine, bromine, or iodine. Is the carbon that this carbon with the hydroxyl is bonded to here. So if we put this together, keep our eye on this carbon. What's attached to it, R prime, which in this case is the hydrogen, our double prime, methyl. I have a hydroxyl group, and then my Grignard right here, 3 carbons. I'm running out of room, so I'm gonna do this. 3 carbons, and I'm done. And that was a lot of fun. Grignard reagent reactions are. Remember, there's 4 bonds to carbon always. All right, your turn to have some fun. And there you go. Give the organic product or products 3 points each. I hope you're having as much fun with this as I do, because it's a Grignard reagent. Big smile. All right, everybody's done, so I better get to work. And if we look at this, as always, and I'm being very honest with you, when I look at a molecule, I scan it and look for functional groups. The way I do that quick is I look for what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond, because it should attract your attention like that. And, ooh, oxygen double bond to carbon. Well, carbon's here and here. This is a ketone. Now it's a cyclic ketone. It could have been an aldehyde. It's not. And remember, in a cyclic ketone, R prime and R double prime are bond together. Then here, what do we have? Carbon, carbon, ooh, magnesium chloride, a Grignard reagent. Remember, X can be, in our case, it is chlorine. It could have been bromine or iodine. That's a better B, sort of. That's better. And second step, acid and water. Keep your eye on the carbonyl carbon. What's attached to that? Excuse me, our prime or hydrogen, our double prime is still attached to it. This opens up to an alcohol, and this, because it attacks that, forms a very special, very valuable, very fun carbon-carbon single bond right here. And now if we look here at this carbon, what's attached to it is the ring with the two methyl groups on there. And this carbon, which is this carbon, will have a hydroxyl group. And what's my R triple prime? Two carbons. And we've made a carbon-carbon single bond. Yay! Dr. White's happy. Even on paper, it's fun to do. And that is my review and extra help for test number 2. And if you want to, feel free to always go back and look at the videos on YouTube. And now let's go back to what we were working on last week. And that's carboxylic acids and their derivatives. And we're just getting into nomenclature. Remember, carboxylic acid, and I have it drawn here like this, carbonyl, hydroxyl group to this carbonyl, and carbons. And this is a carboxylic acid. And how do you name a carboxylic acid? You find the longest chain with the carbonyl carbon, name that as the alkane, and then at the end of the E at the end of the alkane, like methane, ethanol, whatever, you drop the E and add OIC in the word acid. The carbonyl carbon of a carboxylic acid, like an aldehyde, is always number 1, so you don't put a number down. And the rest of the things you name the same as substituents as you've always done. Remember what I'm going over now, carboxylic acids, and the stuff I'll do till we're through today will be on test 3, not on test 2. Again, this is test 3 material. And throughout the semester, I do this often because I always like to finish up early before a test, which we did. I finished up the material last week, and you were able to do the problem set over the weekend. And now if I were to ask, give the IUPAC name for the following, first of all, what functional group are we dealing with? What's different? What's that carbonyl? Ooh, oxygen, carbonyl, hydroxyl group to the same carbon, and carbons here. And this is a carboxylic acid. And how many carbons in the longest chain? 1, 2, 3, 4, 5. Down here would have been 5 too. So remember, it's got to include the carbonyl carbon. 5 is pentane, but it's a carboxylic acid. So you drop the E and add the letters OIC and the word acid. But we have our old friend, the methyl group here, and the carbonyl carbon is number 1. The methyl group is on carbon 4. You don't put a number which carbon is the carbonyl carbon because that's always 1. And everybody knows that. So that's 4-methylpentanoic acid. And that's how you do it. Again, find the longest chain with the carbonyl carbon, carbon double bond to oxygen in a carboxylic acid, name it as an alkane, pentane, then add the letters OIC and the word acid at the end, pentanoic acid. The carbonyl carbon is number 1, so other alkyl groups you can name like we just did. And why don't you name this molecule, which is a very evil molecule? I'll explain why in a second. And give me a thumbs up when you're done, or at least one of the early people, so I can then shoot the poll out. Thank you. All of you who are thumbing up at me. All right, I think everybody's done. So let's take a look at this. What's different? Ooh, oxygen. What's that carbon? What's the hydrogen? Carbon with a carbonyl hydroxyl group and carbons here. And this is a carboxylic acid. And let's count the number of carbons in the longest chain. I start here, 1, 2, 3, 4. But if I start another way, 1, 2, 3, 4, 5, 6, which is a larger number, 6 or 4, and time's up. Hopefully all fit 6. 6-carbon alkane is hexane. But this is a carboxylic acid. So you drop the E, add the letters OIC and the word acid, hexanoic acid. And as soon as you say that, that's all spoken for. Oh, there's something left over. And what is 2 carbons? Alkyl group, ethyl. And what carbon is it on? Carbon 2. Because the carbonyl carbon of a carboxylic acid is always carbon number 1, which you don't put. Now, this molecule is an impurity, a big impurity in a chemical we had purchased from a reputable company that was supposed to be pure something else. And because of this impurity, it gave me about 6 weeks of hell till I figured out, oh, there's impurity in there. And that reminds me, time for a little story. When I started in the chemical industry, I was so fortunate to have first a good boss initially, Bob McDaniel, and I had a great mentor, Sid Shapiro, God rest his soul. And Sid and I actually carpooled for a year, 40 minutes to either of our home or from whoever picked up the other person to work. And every day we carpooled for that year. As soon as we got in the car, he started teaching me things and quizzing me. And one of the things he's always told me was never assume. And I did, and that's where I had trouble with that molecule. All right, now there are 2 important skills you should have in nomenclature. One is, here's the structure, give the IUPAC name. The other is, here's the name, draw the structure. And I'll do one. So here your be 3 points. And how do you do this? You start from the right and move left. OIC in the word acid tells you you have a carboxylic acid. And if this were an E instead of OIC acid, it would be decade, and that's 10 carbons. So I better get to work. And at one end, and I do on the right, you can do the left too, but I don't. I have my carboxylic acid. And then going further, isopropyl group on carbon 3. Carbonyl carbon is 1, 2, 3. Put my isopropyl group. And now it's time to add hydrogens. Remember, if I make a mistake, let me know so I can correct it. And that's how you do it. Oh, it's your turn to have some fun. Let's start with this one. Draw the structure for propanoic acid. Your turn. I was just looking at the calendar. Coming up the end of this month or so is spring break. Wow, it's almost spring. Stop snowing, it's almost spring. And give me a thumbs up when you're done. Well, it looks like everybody's done, so I better get to work. How do you know how to decode this? You start from the right, move left. OIC in the word acid tells you you have a carboxylic acid. And if that were an E, it would be propane, 3 carbons. At one end, and I always do the right, you can do the left, but I don't. I have my carboxylic acid, and I know there's 4 bonds. Yes, 4 bonds to carbon, so I can fill in the hydrogens. That's propanoic acid. And now let's do another one to have fun. There you go. Have fun. Draw the structure for 2,4-dimethyl oxanoic acid. And everybody, I'm going to have to close this and open it again. My computer's saying, burp me. Let's see how good my memory is. You never know. And the one I asked you to draw was 2,4-dimethyl octanoic acid. If you're done, give me a thumbs up. All right, let's do this. How do you do this? You start here on the right and move left. And I see OIC in the word acid. And I say, oh, that's a carboxylic acid. You don't have to say, oh, but this is a carboxylic acid. And if that were an E, octane, 8 carbons. And it's a carboxylic acid. So one end has a carbonyl. That carbon, remember, carbon oxygen, double bond to oxygen, and a hydroxyl group, OH. This is carbon 1. And carbon 2, 3, 4. If I go this way, methyl, di means 2, and they're on carbon 2 and 4. And now I get to put in hydrogens. And that's how you do it, 2,4-dimethyl octanoic acid. All right, let's continue on. Now, there's some common names, and one actually is more than a common name. It's also the IUPAC name. And you should know these. And the first one is formic acid. And formic acid, remember, we're talking about carboxylic acids. And formic acid is when R is H. This is the structure of formic acid. Now, has anybody ever heard of the fire ants? If you can, give me a thumbs up. And I didn't mean see it. Have you ever heard of them? Well, the fire ants are called fire ants. Thank you, Danielle. Fire ants are called fire ants because they have a defensive weapon that when they feel attacked, they spray their attacker with this defensive liquid. And if you get it on your hands, which I haven't, or animal gets it on their skin, they feel like they're being burned by a fire. And what's that defensive weapon? It's formic acid and water that's heated up by the ant's body. And what happens is you get what's called an acid burn. If you get certain acids on your skin, which Dr. White never has, but unfortunately at the other school, I did have 2 students do that because they didn't follow directions. It feels like you've just been burned. And also afterward, the skin looks like you were burned. And that's called an acid burn. And the fire ants are called that because the liquid they spray is a defensive weapon, makes you feel like you just got burned by a fire. Now, the next one is acetic acid. And acetic acid is where R is methyl. And you should know this is a structure of acetic acid. Nobody ever calls this the IUPAC name, which would be ethanoic acid. And you've got acetic acid in your house. Wait a second, Dr. White, I don't have it. Yes, you do. Because if you take about 4% water and about 9, oops, I got that backwards. Whoa, did I get that backwards? Hang in there. Let's try that again. 4% acetic acid and about, give or take, a 1/10 or 2%, 96% water. Mix it together. You have a homogeneous solution. We have a name for that mixture. And what's that name? Vinegar. And vinegar, whether it's white vinegar, not named after me, yeah, right, or apple cider vinegar, I like a lot, or rice wine vinegar, which I use in cooking, those all are water and acetic acid. And the ones that aren't white vinegar have other minor things to give it its nice taste, like apple cider vinegar or rice wine vinegar. But they're all a dilute solution of water and acetic acid that has this structure. Now, next and the last one, this is both the IUPAC and the common name. When R is a benzene ring, you get benzoic acid. Now, benzoic acid is an important chemical because a derivative means something made from, derived from benzoic acid, helps keep our, are you ready for this? Our pop stable in the can, preserves it. And I'll talk more about that in this chapter. but you should know that benzoic acid is both the IUPAC and common name for this. So this is the other two, formic and acetic. I'll never ask you what's the common name, but I can give you the common name and ask you to draw it. But for benzoic acid, I can ask what's the IUPAC name for this, which is benzoic acid, or draw it, because IUPAC took the common name benzoic and made it their IUPAC name. Click right now. I'm turning the next two slides. Will they be ever on test number 3? Because I remember I'm talking about stuff for test number 3. And the, excuse me, the answer is no, it won't. But I'd still like to go over it. Now, again, the switch is off right now. When you have a carboxylic acid, and I have it, the software does it this way. And I could write it this way. When this carbon and this total are 12 carbons, a common name of that is lauric acid. When it's 18 carbons total, CH3, how many CH2 groups you have in the carbonyl carbon is 16 carbons. That's common name. Instead of hexadecanoic acid, nobody calls it that. It's called palmitic acid. And two areas that I worked heavily in the past, excuse me, are when that total is 18 carbons, no double bonds in the R group. That means this right here. It's called stearic acid. And we'll talk more about that. And when it's 18 carbons with a double bond at C9, that's called oleic acid. And when we get into fats and oils, we'll talk about stearic and oleic acid, a lot about it. Now, you can have more than one functional group in a molecule. And switches still click off on this one. And if you have 3 carbons and on the alpha carbon, yeah, this is, now my software wrote it this way. It's also this molecule. And this is called lactic acid. How many of you ever worked out and all of a sudden you feel that pain in your muscles, or you're walking or running? Dr. White's not a runner, but you walk a long time and all of a sudden you feel your muscles are burning. And that is because your body is generating lactic acid. How it does that, I have no clue. I'm an organic chemist, not a biologist or a biochemist, but I do know lactic acid is the molecule that your body produces when you're working out real hard, and it's Mother Nature telling you, it's time for you to stop. And if you ever saw Arnold Schwarzenegger's great movie Running Man, they've got a line in there he uses, or someone uses, no pain, no gain, which I don't know if that's true or not, because my when I've gone to physical therapy, they tell you when you start feeling pain, you should really stop because you're damaging something. But when you feel that burning sensation, it's lactic acid, and it's a carboxylic acid. I assume similar to fire ant, and this is my assumption, in your muscles, if you get that, it causes that burning sensation. Now, something I'm going to be getting into more and more, and I like to warn you. Warn you? Yep. And that is, I'm going to talk about things that are organic chemistry. And I also have a trained organic chemistry mind. And when I see things, I like to think about, how do they do that? And now I'm going to talk about something I'm in no way implying you should use or anything moralistic, right or left or wrong or right about it, but it's in our daily life. How many of you have ever heard of the product called KY lubricant or jelly? And that's a personal lubricant for certain personal how should I say this, activities between a man and a woman. And KY is a very important brand name. If you go to any big box store like Walmart or Target, or as my best friend says, Target, that French store, not really, but anyways, if you go there, you'll see they have a whole big section of KY products. And a number of years ago, they came out with one. It was advertised on cable TV called KY Warming Lubricant or Jelly. I forgot which they called it. And the thing was, you put it on certain parts of where you use that product. And when you use it, you feel a warming sensation. And being an organic chemist, how do they do that? So I went to Walmart, went to where they were selling it, picked up the bottle, looked at the ingredients. Now that won't do it, that won't do it. At the very end, what do you think I saw on the label? Lactic acid. And how they gave that warming sensation where they put this little in, and that was giving you a very tiny acid burn, which was giving you that warming sensation. Now, I assume because of problems with lawsuits or whatever, they changed the formulation, and now they have another way of doing that. It's nothing we cover in this class, but real quick, they have a long chain alcohol, and the moisture on your skin with that alcohol causes hydration, hydrogen bonding to the alcohol, and that warms up too, and safer than an acid burn, I would think. So chemistry is everywhere. Now, how many of you have ever had, or let's do this way, how many of you have ever bitten into a lemon and you go, ooh, is that tart? Is that sour? Or a lime, not as bad. Or somebody makes real strong lemonade, or you use limes and things. Biting a lime, I didn't say that before. What's causing that? Ooh, is that sour taste? And that's the following molecule: citric acid. And citric acid, another way of writing it, my software doesn't like doing it this way. When it's this, has 1, 2, and 3 carboxylic acids. And the switch is off for this page, but I thought this is a structure of citric acid. It's a white solid at room temperature. The more citric acid is in something, the more sour it tastes. Short chain carboxylic acids taste sour. If you've ever done shots of vinegar, no, I haven't, but you've tasted it, it's, ooh, that's sour too. And this is the molecule, the more that's in there. Limes have less than lemons. In other words, lemons have more citric acid. Why? If you bite into a lime, it's that's sour. You bite into a lemon, ooh, that's real sour because there's more citric acid. Now, over the last, I'm going to say decade or so, maybe a little longer, there's been a trend in children's candy to sell really, really super sour candy. I don't like that. I wouldn't buy it, but the kids do because they're selling it. How do they do that? They put more citric acid in there. Now, organic chemists have found a way of synthesizing citric acid in a chemical plant. And that's what they mean by artificial flavors. And if I had the money and the credentials, I could pick up the phone and call a reputable supplier. I don't know now with the pandemic, but before the pandemic, if I had a line of credit, I could have 50,000 pounds of citric acid delivered to my factory to use for making products like that. Now, a couple of years ago, and I still have it, the Spice House, which I've talked about, I don't think they sell it anymore. It's called also Sour Salt, was selling citric acid. When I bought it and they shipped it to me with some other stuff in my order, I wonder how sour this is. I made the mistake of going, oh, is that sour? This is 100%. I just had a little bit, And ooh, I washed my mouth out real quick. Let's do something real quick. Speaking about that. And if you look, and I'm not in any way promoting them, I don't get money from them. You go to Amazon and they're selling it. And you don't need a lot. Boy, I don't know who would need 5 pounds of it, but that's a lot. Even 2 pounds is a lot. And you can get this. Wow, they have large size. Oh, here's 4 ounces. That's smaller. And if you've ever in certain ethnic foods where it's sweet and sour, like Swedish has sweet and sour meatballs, Chinese have sweet and sour various things. They either put in vinegar or something with citric acid in there to get that sour taste. And oh, by the way, Dr. White loves not the American version, but the Chinese or Cantonese version of sweet and sour pork. Ooh, that reminds me. I don't get kickbacks from them either, but all right. There we go. This is Chef Ping in Rolling Meadows on Algonquin Road. And I've been going there a number of years now. I used to go to a place in Schaumburg, but they went downhill when they sold to new owners. And now I go here, and I have been for a number of years. In fact, I go about once a month before the pandemic. I'd go in there with a friend. They already knew what I was going to order. And the stuff in here is amazing. And one of my favorite, not the American sweet and sour, which is right here. I passed by it. But if you go to the back, old time favorites from home, and they mean not American home, but other, and you'll see right here my favorite, Asian style, sweet and sour. I get the pork, not the beef, and I get other things here too. If you ever want one of the best Chinese experiences for Chinese food, real stuff, go here. And the people are so nice. And they do something very different. Unlike other restaurants where if you have 2 or 3 people at a table ordering things, and this is more family style, but even individual orders, once it's done, they don't wait for the whole order to be finished and bring it to your table. So some of the things they get cold, they actually, it's done, they bring it to your table. You don't always get everything at the same time, but when you get it, it's hot and it's good. I haven't been there in a couple of months because of the Omicron virus, but hopefully in a couple of 8 weeks or so, if things keep on going better and the COVID problem gets lower or less, I'm going back there with some friends. All right, now switches off still. This is something I thought I'd run by you. Physical properties of carboxylic acids, and I just use the term acids here. A lot of them lower molecular weight, or have, and a lot of others too, but mainly lower has sharp and unpleasant odors. You don't believe me? Next time, properly smell a bottle of vinegar. Now, the lower MW stands for molecular weight, how many carbons in there have a sour taste like vinegar or citric acid. Now they're polar, and I'll explain about that later when we get into later on something important. And they have high boiling points because they can hydrogen bond, again, switches off on the slide, and the lower molecular weight carboxylic acids are soluble in water. Stearic acid is not, but acetic acid, otherwise known as ethanoic, 2 carbons is. It's called vinegar. Now, let's talk about the acidity of carboxylic acids. Why are they called carboxylic acids? Let me remind you, acid can dissociate to give up a proton, H+. And if you do this in water, what you get, and this is an equilibrium, you get A- and a hydronium ion. And this you should have learned general chemistry. And carboxylic acids can do the same thing, because what is an acid? A proton donor. That's the H and HA. Oh, I have it already. I forgot about. So if you add a base to an acid, you get a proton donor. This gives up its proton here. Well, here in a carboxylic acid, the hydrogen on the hydroxyl group is what's acidic, and it gives up its proton, switches on now to give this is called, and there's a carbon here. This is called the carboxylate anion, which I'll talk more about this chapter. And you donate a proton to water. And that's why carboxylic acids are called carboxylic acids, because they're proton donors, carboxylic acids. And if I look at the clock, oh no, we're just about done. Don't forget, tonight from 5 to 6:15, I have my office hour. On Wednesday, after class, I will send out an email with the password for the password protected PDF file that will be visible to you tomorrow after, I think, 12 p.m. afternoon for you to download and take test number 3 on Wednesday afternoon. And you have until Thursday morning to turn in your answers as a single PDF file. If you don't have a printer, just take a piece of paper, write down your answers, plus the number of the question. Don't forget to put your name on there. And with that, I'm done today. Hope you enjoyed your afternoon of organic chemistry with your host, me, Dr. White. And I'll say, gang gesund. Bye now. I stole that from Granny and Beverly Hillbillies. I'm ambidextrous, so I can do it with both hands. All right, bye.